So welcome, it's a fairly late session already. I'm going to be speaking about Project Hummingbird. So this is something that doesn't exist yet. So this is something that we are researching right now. It's a bit kind of always exciting to speak about something that we are building right now. So first a bit of background, then a bit about web components, how these are related, how we are dealing with HTML templating, a bit about speed in web frameworks, and getting started with this. Maybe 30 seconds about me. So I'm Joonas, hey. Found Vaadin 20 years back and been working around web applications since that time. Unfortunately, my share of code base in Vaadin Framework have been going down from 100% to close to 0. So team has been doing a really good job removing my code lines from the product. So let's see. Where we are coming with the web frameworks. I would like to kind of introduce 3 different axes. So first axis being, are the apps single-page apps or multi-page apps? Or are we kind of concentrating on templating or components? Or are we server-side or client-side framework? So there are multiple dimensions in every web framework, but these are the ones that I'm particularly interested in. So looking at a couple of frameworks, JSF, multi-page, mostly component-oriented and completely on the server side. Or GWT, completely opposite. Or Angular, single-page, fully based on templates. So this is Angular 1, and fully on client side. Angular 2 being really embracing components, but building those components out of templates. So it's kind of interesting trend where they are going. And also they are adding a bit of server-side rendering as well. So the question goes, what is kind of optimal balance between these? One really interesting framework is Polymer, if you can call that framework. It's fully single page, fully client-side, and web component oriented. But it also is using templates for building those components. Vaadin Framework traditionally have been fully single page, fully on the server side, and very component oriented. There is a bit of templating in there, but it's very, very component oriented. So where we are going next is kind of shifting to a better balance between server side and client side, and also emphasizing templates more. So let's see what this actually means. Who have been using Vaadin Framework? Anyone? So I'll give a kind of a brief intro to the ones that haven't been using Vaadin Framework. I'm not going to be going into details. So it's a web framework that is really popular around enterprise applications for building business apps with Java. And we have around 150,000 developers using that. The basic idea is that we'll kind of combine Java and web, or kind of bridge between Java and web. And how it's done is that we are building on top of components, and we've been doing that since 2001. So it's really, really long effort embracing component-based programming model. So our kind of we started from looking at things like Delphi and Visual Basic and thought that it would be cool to kind of bring these over the web, and we started building on top of Java, and there we are. So if you think of those components like layouts and text fields and buttons, these all are on the client side really. So they are not on the server side, they are on the client side, visible on the web browser. But our kind of key value have been that you are able to control these components from the server-side Java. So for each of these components, we have a server-side counterpart. So for a button on the client side, we have a button on the server side. And you can do the same composition on the server side. And when you kind of add component to that component tree or manipulate components or listen for events, all of these are happening on the client side as well. So it's kind of a puppet where you can kind of pull the strings and the client side follows. And that's have been a really kind of powerful development model for if you are used to building things in Java, because you don't have to worry about communications. It already runs on top of WebSockets without you needing to know all the details, or it's already kind of secure in a way that you don't have to build authentication for each of the APIs that you would be publishing, or you don't have to worry about browser differences or writing any JavaScript. So it's kind of really productive environment for a Java developer. So that's the background. Of course, we have some tooling around it as well, like visual designers and testing toolings and so forth. We have released the most recent version 8 just a month ago. So there is a fresh new major version out there for you to try. But I'm not going to be speaking about that. I'm going to be speaking about what comes after that. So if you're interested in 8, grab a Vaadin book or go to vaadin.com and try it out. It's free, open source, Apache licensed. You can use it for anything, and it's used by many, many big companies around the world for building business apps. So what comes after that? So if we kind of look at this picture, this is, by the way, Vaadin Framework logo at the same time, not just a kind of architectural diagram. So if you look at this, these things, they actually are separate. And for past 16 years, we thought that this is one package that cannot be separated. We have a bunch of components and a communication mechanism between browser side and client, between browser side and server side. But if we kind of take these two parts apart, we do have a set of elements that would be usable for any front-end developer, whether they are using jQuery and PHP or whatever. And then we have a communication bridge between browser and the server. So we decided that it would be cool to kind of take these things apart and open up these things for developers that only are interested on a part of it. So in a way, for a communication part, you could actually use that to control any type of web UI, any type of components, any type of DOM. And for the elements, you could use these with any framework. So we started exploring that. And if we look at a bit of a history, we started from 2001, and we have a long series of Vaadin Framework releases. And in all of these, it's kind of monolithic. It has components, it has the communications in one. And a couple of years back, we started building those elements on the client side as a completely separate track, nothing to do with Vaadin Framework. And what we are doing next, we are basically putting these two things together in a unified platform where you can use either side or both sides together. So let's take a look at these two sides. First, the elements parts. So they are just components. And actually, I think like 4 years back, Chrome team started talking about web components. And that was a kind of really exciting idea to us. We kind of thought that, hey, now people are grasping on the web front-end side that actually UIs are built out of components. We've been doing this for many, many years already. But it was also kind of a scary thought. So if components are well implemented within web browsers as a standard part of the web platform, what's the use for Vaadin Framework? Will it kind of kill us? And we started exploring things on that space and decided that this is a really exciting development on web platform that we want to be part of. So the current state of the standards is that there is a ready-made standard for HTML templates. That's one part of the puzzle, so to speak. And then there are a bunch of standards, shadow DOM, custom elements, and HTML imports that together form a set of standards that could be used for building web components. Anybody building web components yet? One guy. So the state today is that HTML templates, they work quite well on all the modern browsers. I don't count IE 11 as a modern browser. But the sad fact is that the rest of the standards, they don't work that well yet on current browsers. So shadow DOM part, it works in Chrome, and that's about it. Or Blink-based browsers, basically. Custom elements, they kind of work in more browsers, but there are some limitations as well. HTML imports, just Blink. And that's a bit of a problem. So Google started a project called Polymer, and that was originally more of a kind of glue for using these upcoming standards in browsers that didn't support them yet, kind of polyfilling those features in current browsers. And that worked quite well. and then they noticed that it's not enough to just make the standards available, but actually you have to think about how should you apply these standards to build those components. So Polymer shifted to be and become best practices way of building web components. And when you had web components, you started building applications with that, and now Polymer is shifting to be an application framework, or kind of going to that direction. Really exciting project, truly recommended to take a look at that. They are just coming out with 2.0 version, and it's a really cool way of building web components. And this is, now it's a kind of opinionated thought. I really think that web components as a standard, it's the next leap in web platform. It will be the way how web apps are built in the future. So this is different frameworks, React and Angular and so forth. They have been, and Vaadin as well, we have been kind of trying to build component models for a while, but it's built on top of web platform that didn't support components. Now when the web platform really supports components, we should embrace that. And I think this is something that is becoming after all of these. So how do you use a web component? In Polymer, you would use Bower to just download a component, in this case, paper slider. You can see a paper slider in here, and you just use it as any standard element on web page. The only thing in web component is that you have a dash in between the HTML tag that kind of notes that now it's a web component. The key in this is that the implementation is fully hidden. So this is just the kind of web API for it. You can set the value, and that's about it. You don't see how it's implemented, how all the animations and slider are implemented. So what our take was that we started building those components. So now we have good bunch of components. So this is a component set built on top of Polymer, using web best practices, having around 70 components when combined with Polymer paper elements. And there are also good examples on how to build applications out of these components. So if you go to our site, you could use those, and they're all free as well. So what's next in here? So the next steps on the element side is that we'll add a theming engine in there, make this compatible with Polymer 2. Most of the elements are compatible with Polymer 2 already, but some of them are not yet. And we'll basically need to expand the set in a such way that it could support building any application that we have been able to build with Vaadin Framework. When we are at that stage, then we could use these for the next generation of the Vaadin Framework. So that's the element part. As an example of one component, I would say the most exciting one is data grid. They're always the kind of most interesting components. This one is something that is coming out really soon. I assume beta next week. And it has most of the features you can imagine in data grid. So it's unlimited rows, variable row heights, drag and drop in columns, multiple headers, and so forth. What is cool in here is that it fully supports templating from Polymer, so you could easily build really customized features like this picture in there, just with a couple of lines of HTML. So if you need a good data grid, regardless of which framework or stack you are using, this is a good candidate. It doesn't cost anything. So the actual topic, Vaadin Framework, what's happening around there. So now we are in 8. It's a really mature framework. It's used every day to build and run thousands and thousands of applications by 150,000 developers. So what's the next stage with that? So to explore that, we started what we call Project Hummingbird. This is an internal project at this stage. We started that a couple of years back. And we wanted to have answer to 3 different questions. So first one is that, is there such a technology on the horizon that will completely change how web platform is working and how frameworks are coming together? And yeah, I think there is. So that's web components. that is a kind of major drastic shift in web platform and what you can do with that. One could argue that after that, progressive web applications are the second shift, basically making native apps, at least for business purposes, more or less unnecessary. But it kind of builds on top of this. So web components and progressive web applications are really well compatible things. So the second thing was we saw Angular over the years skyrocket. Why did it become so popular? Does it have a cool logo, or is it just fun to use, or what's the kind of power, what's the magic sauce in there? And then there started to be many other front-end frameworks that were building around the same concepts. Why are they so useful? Could we have some of that magic built, isolate the root cause for that and kind of make sure that this is part of Vaadin Framework as well? And the third question was basically, what are the limitations that we are having? And the basic limitation that we always have had is that it's fairly poor for building websites. Now, as a framework guy, it's a bad thing to say aloud, but that's true. So it always has been building web apps, especially internal web apps, those that are running all the big corporations, replacing your Swing desktop apps. But for public-facing websites, it's not a good choice. So could we kind of fix that part as well? So these were the three defining questions we started researching a couple of years back. And just to dive into the results. So first, web components. So this is how you could actually use a web component from Java. So it's fairly straightforward with Hummingbird. You just say that I want to use this paper slider component. So the tag is paper-slider, and that's it. You import the component, and you don't have to do anything else. So basically, two annotations and empty class. On the client side, nothing. And with this, you can use this paper slider from the server side. Of course, it's not too useful yet. You can slide it around, but that's about it. To be able to kind of put that on the screen, you just add that on a component tree to any kind of view. In this case, this is a view based on a div. To start kind of changing and kind of sending and reading information from the browser to the server, that's a kind of tricky part for every web browser, every web framework. And we made that super easy. So this is server-side Java code. And as you can see, this looks fairly familiar. These are the same methods that you could use on the client side on DOM. We just made those available to the server side. And we made them fast as well. So you could actually just traverse through the DOM and read the value or set the value. And rest is automated. So with these, everything goes over the wire automatically, and you don't have to do anything else. So you could take anything web. It doesn't even have to be web component. It can be just a plain web page, and start manipulating that from the server side with a couple of methods. So this is not yet kind of listening for events, what's happening by on the web browser side by the user. For that, you could just declare that I want to, for this component, listen for value change events with one annotation. And after that, you get called anytime the user kind of changes the value and basically emits this value change event, you get a call on the server side on this method. So does it seem useful for developing things from the server side? Or just pure magic? So that basically kind of glues web and Java together in a really efficient way over WebSockets. And all the communication is automatic. It automatically determines if you have WebSocket available. If not, it uses just AJAX calls. But you don't have to worry about that. That's the only code that you have to write. So the second part, why Angular got so popular. I believe that they kind of cracked the similar problem as Excel or spreadsheet cracked for business apps. So they started building templates where you can refer to data models in a really easy and powerful manner. So we decided to bring that over to Vaadin. And actually, the name of the talk was also referring to Angular. So what we did, we actually brought Angular 2 templating to Vaadin, implemented that in server side and client side, and it worked out well. And then we thought that it's not kind of a too unified platform if you have Angular templates and Polymer components. So we decided that we'll go all in with Polymer when Polymer 2.0 brought quite a bit more powerful templates. So now we have a Polymer-based templating. As an example, if you would build an app like this, really simple, showing my name, you would build a component in Polymer as a template plus bit of scripting. This is how we declare it. This is client-side Polymer today. On the template side, you would just declare an input and a button. But the cool thing is that you can also have like ifs and loops and whatnot in here. And you can bind to data directly with this kind of notation. So this is reading from the data model, automatically updating on the screen when the data model changes. And the server side, the scripting side is just basically declaring the tag and adding this tag, registering this tag as something that you can use on the web page. And this is actually standardized way to do that in web browser. So this is not Polymer specific. And of course, you have event handlers, so you can call for this say hello. So you could call any method. So that's standard Polymer on the client side. On the server side, the only thing that you have to do to be able to use this template is actually, instead of extending from component, extend from Polymer template. Or if you'll be using Angular templates, you can extend from Angular template. And there is one kind of key in here. There's a data model. So this declares the data model that automatically gets synchronized between browser and the server. So the data model looks like this. We just have a text in there. So when we have declared this data model, you can, from the client side, read from this data model. And then you can also start listening for events by declaring something as an event handler. So basically, this server-side code gets published on the client side, and client-side events get routed to this server-side code. So everything is automated in there. You don't have to do anything else. So fairly powerful way of gluing templates in there. So the third piece of the puzzle was websites. What could we do about that? And it's all about speed, especially startup speed. So if you start Vaadin application today, it gets a bit of time to load the widget implementation, that's like 300K of JavaScript. And it kind of sends back and forth a couple of requests, so it takes some milliseconds to load. But you can notice that. You can feel that it's not as fast as, let's say, opening up twitter.com. So we started fixing that. I don't know if we have enough time to show it. So let's see, maybe just a couple of examples. So this example is recorded on Java 1 on their conference network, not the best network. And this is now accessing Vaadin-based application, traditional Vaadin-based application. And it takes a while to actually get that loaded in there. This is actually a huge application with tons and tons of images in there as well. But it wouldn't be usable as a website. And this is our next website, so we had to fix this. So what to do to fix this? So we came up with pre-rendering. So this is the same scenario, no caching, same fairly, let's say, conference network, but pre-rendering enabled. So if we do the same thing, set the throttling off and disable cache, and start loading this right now. So now it loads almost instantaneously. And there is no code changes in this. What we did, we basically rendered the web page automatically on the server side, sent that over the wire, so that you can see it immediately, basically as fast as a static web page. And only after that, start pulling the resources in and kind of adding the interactivity to that. So it's kind of fairly big shift for a server-side framework, or actually any component-based framework. Angular 2 is doing the same on the if you go into the server-side rendering mode. But then we started thinking that, is this good enough? There is something really interesting around the corner called PRPL. Who has heard of this? So this is push, render, precache, lazy load pattern. You can Google for that. So this is Chrome team's vision on how to make the loading really, really, really fast. And the cool thing about this is you don't have to do pre-rendering. So pre-rendering is a fairly complex thing to implement. We did that, but it's we would rather not maintain that if anyhow possible. So this is riding on top of HTTP2. And as you know, in HTTP2 protocol, you can mark resources that these are loaded immediately side by side in the same stream. So this is the pushing part. It pushes all the resources needed to render the first view at the same time when you are accessing for the first HTTP request. And this is really fast. So you have everything to render when the web page loads, and it loads as fast as pre-rendering. And pre-caching and lazy loading some resources that you may need later on, that's like fine-tuning part of it. But I don't have time to go into details with this. A couple of other magic tricks that we are building into the framework is latency compensation. So basically, in server-side framework, you go to server-side to do some actions. If the server happens to be on the other side of the globe, there is light speed that is kind of limiting the feel on how fast is the interaction. So with this, we can actually kind of trick the light speed, guess what is the change that is going to be happening on the screen, do that immediately, and when light goes to the server and back, then kind of correct the state of the screen to correspond to what server actually wants to show. And the final trick is client-server hybridization. The whole stack is built in such a way that you can combine server-side programming with client-side programming. So you can build a view completely on the server side, and if you feel that it should be on the client side for some reason, most probably because you want to access that offline, you can use it that way. Okay, that's basically it, and I'm running out of time. So how to get started? I have a really quick tutorial for you. No, really. You can get started by trying out Vaadin Framework right now. It has the same concepts, and we will be supporting all the applications that you're building with that on the next generation as well. All those elements are available today. You can go and try them out. And actually, one thing that you could do, if you're really interested about this, we are looking for a limited number of people who want to try it out and comment on it before we release that publicly. So if you're interested, shoot me an email, and I would be happy to connect you with the development team, and you could try it out. So that's it. Thank you.